All right, so this is transformations for both exponentials and logarithms. And this is like the 5th or 6th time this year we've done transformations. So if you don't have a general grasp on them by now, we have a problem and we need to talk. And that's okay, but we need to have that conversation, if that's you. But we'll figure that out one way or another. Here we go. So 7.4, transformations to exponentials and logarithms. Remember, really the biggest idea is what is inside or what is outside. So inside the parentheses is what values, x or y? X. Is it normal or backwards? Backwards. Backwards. Outside the parentheses, is that x or y? Y. And that, we treat them how?
Normally.
Normal. Alright, so your biggest question is what is inside or what is outside? So, this top one here, this is the exponential ones, which both of these charts are essentially the same. I mean, they really are. And they're the same chart you've had it before, just things are in different locations. So inside the parentheses for an exponential, so let's say I have a y equals 2 to the power of x. X is the exponent. That is inside. Okay? That portion right there is what is inside the parentheses. So anything that's not as an exponent is outside. Anything that is the exponent is inside. Now, the base itself, we are not going to worry about. The base can do one of a lot of things. The base can actually stretch, it can shrink, it can... Actually, the base can reflect it as well. So, we are not going to be playing with the base. Now, we might multiply it by something up front, like put a 4 times 2 to the x, something like that. But the base we're not going to worry about. We'll put different bases up there, but we're not going to worry about that. The second one, the logarithms. Again, the same rules apply. You just have to know what's inside. So if I've got y equals log base 2 of x, anything that is inside there, your argument, that it will be inside. So anything added or subtracted out back, that's outside. Anything multiplied out front, that's outside. And if you divide the whole thing by, like, say, 4, that's outside. All that sort of stuff. And again, your base. We're going to give you different bases throughout this, but don't worry about that. Okay? That does something that is a much more complex problem and not really something we need to deal with. All right, the charts. The charts. Again, just a quick run through of how to run the charts. So if you know you're inside, okay, and you're subtracting, it's like, oh, I'm inside and I'm adding. Okay, so that's an add on the inside. Well, that means it went left. You shifted to the left. Or if you're inside and you know you subtracted, will you follow along and that means that's my transformation, 3 units to the right. I shifted 3 units right. Okay. If you multiplied, well, you got to know inside or outside. If I multiplied inside, okay, is it, did I multiply by 2? Or did I divide by 2? Or did I multiply by something or divide? And just follow the chart on over. Okay, it's the same thing y'all been doing. Now, I will say this. I am not giving you this page on Friday. Okay? It's time to get the training wheels off and kind of keep running with this. You'll have had enough of it kind of with the chart. It's time to just do it. Now, if you want to write this on a little note card or rip off a piece of paper about that big and write the whole thing down, I'm fine with that. I'm fine with that. But I'm not giving it to you. Follow me?
Wasted paper.
Yeah. I'm not doing it because it was a waste of paper, but I think it's time for you to grow beyond that a little bit. All right. So here we go. Turn the page. So first things first. To do these, you have to write 3 things. You have to write what it is, the direction it's going, and how far. Okay, you have to say what it is, what direction it's going, and how far. And there are 3 types of things you come across. There we go. You might be adding or subtracting, which if you're adding or subtracting, remember what type that is. The other S. Not a shrink, it's not a stretch, it's a shift. Thank you. All right, if you are, and your book calls it a translation a lot of the time. If they say the word translate, not transformation, translation with the L, that's the same thing as a shift. If you are multiplying or dividing, you could be doing one of 2 things. That's the other 2 S words. That's a what? Stretch or shrink. depending on where it is and how. Last but not least, if you multiply or divide by a negative. Wow, that's just horrible handwriting. I'm zooming in to fix this. By a negative. What is it? Good, it is a reflection. Okay, if you multiply or divide by a negative, that's a reflection. Okay, so those are the four types. The directions, up, down, left, right, horizontal, vertical, and how far, which just grab the number. So letter A. Like I said with this, do not worry about the base, that 1/2 base. Don't worry about that. We're not going to change that. If we do change that from one equation to the next, that's either a typo or I assigned a problem I shouldn't have. You follow me on that? And you can just exit out and keep on going. But anyways, so what is the difference between these two equations? The -4. Okay. So if you subtract 4, what type is that? It is a shift. Is it outside or inside? So does it go up or down? Down. Good. So shift down. How far? 4. Okay. For those of you who like to use the chart, if I go back here, again, we added or subtracted outside. Well, here's your outside one. We subtracted, so this is the track that subtracted, which means we go down. We shifted 4 units down. Okay? Erase. The next one. Now, this is a complete typo. I have no idea how I got that in there without doing anything about it. So we're just going to go e to the x, let's do +3. Okay? What is the difference between f of x and g of x? +3. The +3. Is the +3 inside or is the +3 outside? Ooh.
Outside, boys.
It is inside. Where is inside in an exponential?
On the bottom.
It's the exponent. Is this part of the exponent? Then yeah. No, there are no physical parentheses for this one. But that is what we consider inside, is where is the exponent? That is considered inside. So if we're adding 3, so what type is it? It's a shift. We are inside, so we have to go either left or right. Which way are we going? Left or right? Left. Because it's backwards. Left 3 units. Okay? It is inside, so it's backwards. It's really going left. That's the effect it has. And again, if you want to, this is your inside one. Follow the add. This is the one where they added, and it goes left. Okay? You can follow your chart that way as well. That is fine. All right. Don't do letter C because it's a carbon copy of letter A. Do letter D real fast. Take a second and do letter D. And if you have to flip to your chart, go for it. Probably because I want to flip you off, but I can't really do that. But okay. Anyways, I'm kidding. Let's keep the. Back on. Which one do we got? Do you want to talk about the 2 or the 4?
4. Number 2.
The 2. Okay. This 2 is out front. What's it doing? Well, let me ask you this. Is it a stretch, a shrink, a shift, or a reflection, that 2 out front? It is a stretch. Because it's multiplying. Which direction? Vertically or horizontally? Vertically, because it's outside. So it's outside, so it's vertical, and it does exactly what you think. And by 2. It's a shrink. All right, what about the 4? You're adding, so we automatically know it's a what? Shift. Does it go to the right, or does it go to the left? Ooh, why is it left? Because it's in the parentheses. It is the opposite, so it's a shift left by 4. Cool. What What are y'all doing back there? Come on. All right, let's do one more on this page. Let's do letter D. No, I want to do letter D.
Oh, no.
There are two numbers you have to deal with. What is one of the numbers you have to deal with? The 4 on the inside. Okay, what else you got to deal with? The 5. Okay, take a second. Deal with both of those. Which one you want to deal with first?
4.
The 4. Okay, so what is the 4 doing?
Horizontal shrinking.
It is a horizontal shrink. Good. It's a horizontal shrink.
Oh.
Why is it a shrink and not a stretch?
Because where the horizontal shrink is okay. It's the opposite.
Because it's the opposite. I think that's what you were trying to say. You were getting that roundabout. You're right. It's multiplying, but the effect is as if it divided. And if you want to write by 4, by 1/4, I really don't care. What about the 5? What does the 5 do?
Shift down. 5, yeah.
Perfect. All right, how are we doing with all this? Give me 5 to 1. 5, I got this form. Okay, 3 and 2 and lost 1. Save me. Sweet. I told you I'll pick up on this actually pretty quick. All right, turn the page. I want to do a couple of these real fast, and we'll cut you loose. All right. Let the graph of G be a translation 3 units to the left. 3 units to the left, followed by a reflection in the x-axis, followed by a translation 4 units. I don't want to go right. I want to go down. So scratch out the word right and let's go down. Down. We're going down. All right. Of the graph, f of x is 2x. So we're starting off with 2 to the power of x. If I go 3 units to the left, yeah. If we go 3 units to the left, where and how do we do that? Okay, hold up. If we are shifting 3 units to the left, first things first, are we adding or subtracting?
Subtracting.
Where?
Wait.
You're adding on the inside.
It's on the inside. If you go left, it's got to be on the inside. So, come on. Where do you add on the inside for this? In the exponent. Good. So that would be 2 to the x plus 3. We know it's an inside thing, so it has to go in the exponent, and it is backwards. All right. To reflect in the x-axis. Reflection is when you multiply by a negative. So do we need to put it out front, or do we need to put it on the inside? Outside. It's across the x, so it's going up and down to cross that x-axis. So we need a negative 2 to the x plus 3. All right? Then translating 4 units down. Well, translations, that's just a shift. So are we doing that inside or outside to go down? What is it? Outside. Good. So are you going to add 4 out back, or are you going to subtract 4 out back? He's right. You're going to subtract 4 to go down. So y equals all of that. Now, here's the deal. If you want to do this in one big crazy equation all at the same time, that's fine. I really don't care. Or you can just start with the base and just keep adding whatever piece you need. That's fine too. This is easier on your brain, I'll give you that. So let's keep that up. All right, letter B. We're dealing with a logarithm this time. Let the graph of G be a translation 2 units up and 3 units left. So those are your shifts, those are your translations. Followed by a vertical stretch by a factor of 2. I'll do that in blue. Of that graph. Okay. So the original, it's a logarithm this time, so log of 1/3 x. All right, to go 2 units up. Is that inside or outside?
Outside.
That's outside. So you're going to add 2 or subtract 2? Add 2. So we're just going to put 2 units out back, which that, believe it or not, is actually outside. for the logarithm, to show that that 2 is on the inside, you actually have to put parentheses around it. That would be inside. But in reality, it's still outside. Okay, to go to the left, is that inside or outside?
Inside.
Inside. So to go left, would you be adding or subtracting? Adding. So let's add that one. Log of 1/3 would be x plus 3 plus 2 on the outside. And no, you can't just break the parentheses and put that 2 in there and make it a plus 5. All right? This parentheses is part of a log. There are ways of breaking it into a log. That is not how you do it. All right, the last thing, to vertically stretch by a factor of 2. All right, so to vertically stretch, is that an inside or an outside thing? Outside. Why? Because horizontal is on the inside, vertical is on the outside. That's your y stuff. You're absolutely right. So to stretch by a factor of 2, are you going to multiply by 2 or divide by 2? So y equals 2 log of 1/3. That's a 3 down there. X plus 3 plus 2. Let me zoom in and fix that. Stop on with the eraser. 1/3. Cool? Again, feel free to do it in chunks, because the odds of you getting into this in one shot, you can do it. Yes, I agree, you can. But it takes more brain. It takes more brain power. All right? There's nothing. You're not smart enough. It just takes more energy. I'm all for the path of least resistance. All right, try one on your own. Do letter C. Do letter C. Yeah. Did you make it?
I just put the parentheses.
Oh, if you put the parentheses, okay. For an exponent, you don't have to with an exponent because it's up high and small, so it's kind of assumed. But I mean, it's not necessary.
I got it right here.
Cool. I want to do one more. Well, yes, ma'am.
Okay, so for translation, 2 to the left, I thought that was opposite.
That was inside, so that's inside. Left is the negative direction, right? Yeah. You're right. Yay! All right, last one and we'll call it a day. Thank you very much, ma'am. Letter E. I want you to do letter E. No, I don't. I want you to do letter, I want to do a logarithm. Yeah, do letter E. I like E better, even though it's not a log. I really do. I like E better because it demonstrates something else. I mean, honestly, if you can do it with an exponential, you can do it with a log. Wow.
Jonathan, I'm talking to Jonathan. And the kid with
Y'all are special. I love this. Thank you. All right. There you go.
Yay!
I knew it, man.
I was gonna do 1/3 maybe.
Okay. Yeah.
What if we just put a 3?
If you put a 3 instead of an X.
No, the 3 answers
Yeah, okay, so here's the deal. If you did to that, this is multiplying on the inside, right?
That's why I didn't do that, because I was like, that's multiplying.
Yeah, that's multiplying, and that would actually shrink it, because everything's backwards. To stretch, you have to divide. Now, if you wrote it like this, well, that was my prepubescent boy coming out. This. If you wrote it like that, that's fine, because dividing by 3 is multiplying by a third. Alright? But other than that, are we all cool? Even with that, are we all cool? Alright. I'm calling it.